Hello, fellow educators, and welcome. Today, let's break down, in detail, the ICSE Class 9 Computer Applications Syllabus. We'll explore its structure and key components. This syllabus is a roadmap meticulously designed to help you inspire and empower your students in the world of computing. This course isn't just about the superficial use of computers. It's fundamentally about understanding how they work, delving into their inner mechanisms, and more importantly, how to harness their power for problem-solving and innovation. The syllabus thoughtfully balances theoretical knowledge and practical skills, ensuring students not only grasp the core concepts, but also learn their real-world application through hands-on experience. Our primary job as educators is to spark curiosity and to make the often intimidating field of computer science accessible, engaging, and genuinely exciting for every student. The curriculum starts right from the basics, covering hardware, software, and progressively builds up to more complex programming logic and problem-solving techniques. It's thoughtfully designed to cater to students from all backgrounds, so that every student, regardless of their prior experience, can build confidence and succeed. Together, we'll explore each component of this syllabus in detail, starting from the core concepts to practical exercises, hands-on activities, and effective assessment strategies. So, let's get started right away and unlock the full potential of this syllabus, empowering our students to excel in the digital age. The syllabus stands on three crucial pillars, each designed to provide a comprehensive learning experience. First, theory, then practical work, and finally, internal assessment to gauge understanding. Theory covers the fundamentals, the bedrock of computer science knowledge. This includes operating systems, programming logic, the very core of how computers function, and Java basics, providing a solid foundation in object-oriented programming. Practical work is where students actively write and run code, effectively turning abstract theory into tangible, hands-on skills. Encourage experimentation. Let them explore different approaches. Remember, mistakes are valuable learning opportunities, not setbacks. Internal assessment is an ongoing process, based on programming assignments and projects completed throughout the year. This continuous evaluation meticulously tracks progress and significantly reduces the pressure associated with final exams. It's vital to integrate theory and practice, teach a concept thoroughly, then immediately apply it in code. Use practical sessions strategically to reinforce learning and actively build essential problem-solving skills. Keep assessment records clear, organized, and provide feedback in a timely manner. Together, these elements synergize to create a holistic and truly engaging learning experience. This well-rounded approach effectively prepares students to confidently face future challenges in the field. The theory section is designed to lay a solid groundwork, and it all begins with object-oriented programming, a cornerstone of modern software development. We'll explore objects, the fundamental building blocks, and classes, which serve as blueprints for creating these objects. We'll also delve into abstraction, simplifying complex systems and encapsulation, bundling data and methods together. Use real-world analogies like cars and models to illustrate these concepts, making them more tangible and easier to grasp. This approach helps to make these sometimes abstract ideas relatable and understandable for every student. Next, students dive into Java, a widely used and versatile programming language. We'll cover data types, which define the kind of data a variable can hold, and variables, which store these values. We'll also explore operators, which perform operations on data, and the fundamental structure of a Java program. Start with simple programs like the classic Hello World to introduce basic syntax and program execution. This initial success is crucial to build confidence and encourage further exploration. Then introduce control structures, the building blocks of program logic. We'll cover if-else statements, which allow programs to make decisions based on conditions, switch case statements, which provide a more efficient way to handle multiple conditions, and loops, which allow code to be repeated. Use flowcharts and pseudocode to plan out the program's logic. This will help students visualize the logic before diving into the actual coding process, making it easier to understand and debug. Cover basics of hardware, the physical components of a computer and software, the programs that run on it. Also, explain number systems, including binary, which is the language of computers, for context. Explain how computers represent data internally, using bits and bytes. Clarify the difference between operating systems, which manage computer resources, and applications, which perform specific tasks. Connect these foundational ideas directly to practical programming tasks and real-world examples. This comprehensive approach helps students see the bigger picture and understand how everything fits together. Make each topic digestible and relevant to their future programming endeavors. By doing so, you'll build a strong base of knowledge for more advanced learning and complex problem-solving. Practical sessions are where students become real programmers. Assignments cover input, output, conditionals, and loops, mirroring theory lessons. Use relatable problems like calculating student averages to make coding meaningful. Encourage pair programming for collaboration and peer learning. Students should maintain a portfolio problem statement, algorithm, code, and output. Emphasize documenting logic before coding. Teach basic debugging, using print statements to trace errors. Foster a classroom culture where mistakes are puzzles, not failures. Celebrate breakthroughs and persistence. This hands-on process builds resilience and critical thinking. Good habits now set the stage for future success. Assessment in this course is thoughtfully split into two key parts. First, there's an external written exam, and second, an internal practical evaluation that really tests hands-on skills. The written paper is designed to test both breadth and depth of knowledge, featuring both short answer questions and more complex programming problems. The internal assessment component is primarily based on the comprehensive student's programming portfolio and their individual project work. We carefully evaluate algorithms, ensuring code correctness and the quality of their documentation. We also use regular quizzes and engaging programming challenges to really reinforce learning and understanding. Mock tests are invaluable, helping students prepare thoroughly for the final exam format. It's crucial to provide clear guidelines and rubrics right from the very start. And remember to give constructive feedback consistently to support continuous improvement. By carefully balancing theory, hands-on practice, and plenty of encouragement, you'll effectively guide your students towards success. Your passion and dedication can truly ignite a lifelong interest in the fascinating world of computer science.